Hey, Maddie, thank you for coming in. You just have a remarkable background of contribution and impact, and continuing to do so to really transformational globally. So thank you for coming in and sharing your insights with my audience.
Thank you, Stephen. I appreciate it.
So Maddie, my first question is about what made who you are today. And you're still very, very young, but you're doing just amazing things, outstanding globally. What were the things like maybe the three inflection points in your life? And it could have been when you were like 3 years old or five. It could have been inside, outside the family, inside, outside the school. It could have been some jobs you've taken on, projects you've taken on, mentors you have or had. But what were those three pivotal moments that created who you are today?
Wow, it's a great question. I think the first the first one would be when I was about 6 years old, and it was in my grandparents' place where I would spend most of my weekends as a kid, and I had this kind of game where I was pretending to be running a shop like a small store, and it occurred to me that I should have a website for my fictional store as a kid. And so I sat down at my grandparents' computer. It was like this super old LG that took like 5 minutes to boot up. And I just Googled how do you build a website, and that's how it started. So that's how I got into computers. I was spending a lot of time just building my website, and then I of course expanded that to like programs and like actual coding and Java and Python. So that's how like that interest kind of sparked in me, and ever since then I've been as a kid a part of like coding clubs or different classes and communities. So that was, I think, a pivotal moment, just like that that like interest in building a website for my fictional store as a kid really inspired this interest. So I think that's one of those moments. I think another one would be with Dr. Rus from the Czech Republic. So I was born and raised in Prague in the Czech Republic, and I had this idea. I think this was freshman year of high school. I had this idea to build an app to translate sign language from video to text. And when I embarked on this, it seemed like a super simple app that I could build, but only only as I got into it that I realized that I actually have to do a bit of research, because it's still to this day like an open research question. It's not solved, and there was this research group in the Czech Republic that had been working on things pertaining to an AI accessibility. And so I reached out. I built this super simple prototype, but it did work for some signs. And I reached out as a freshman at high school, and they were so kind to welcome me and give me space to present my idea. And then they started mentoring me, and it's really quite remarkable for Eastern Europe, I would say, to do that, because um the kind of approach to letting folks into universities or into companies is very different. I think that here in the US, people are much more open to let kids or teenagers get that experience. I think it's very different just culturally in Eastern Europe. So that was really remarkable. He gave me a lot of mentorship and really showed me what science and research in computer science is all about. So that was another pivotal moment, I would say. And you said three, right? Uh, so one more would be with Professor Farid, who is my advisor now. We were connected through a mutual collaborator, and this was, I would say, sophomore year of high school. And Professor Farid, after some time, offered a job at his lab. So I was working with Professor Farid remotely from the Czech Republic as a high schooler on research. And then the first summer, he had me in Berkeley when I flew out, and I spent my summer in Berkeley working on research. Like that was really transformational, just like seeing Berkeley and the US and the vibe and the energy that people had for computer science, for AI, for innovation, for doing like hard work that was not just about papers, but was really about like impact and change. That was really transformational. So that summer in Berkeley really made me restructure my goals and where I wanted to be. So I think those would be my three moments.
So, did you say that you got exposed by your grandparents to a computer?
Yeah, that's right. But they were not computer scientists. My grandma did work in chemistry research and in chemistry kind of scientific fields, but they were not computer scientists. They just had a computer there, and they were not using it that much, so I could use it.
So this was in Prague, then. This was in Czechoslovakia. Czech.
That's right. That's right. Czech Republic. Yeah.
So your grandparents were professionals in chemistry, like in the science field, but not in computation. But they had this computer that really wasn't being utilized. And you were, what, 6 years old, and you decided to play with it or something like that?
That's right. Yeah, that's right.
And you thought, maybe I can build a website. So you kind of taught yourself how to do that. And then from there, you got an interest in Python and programming languages.
Yeah.
And then when you were a little older, you got exposed to a group in Prague on this research. You had this idea that maybe you could maybe combine elements of programming with recognizing sign language and things like that. You thought it would be an easy problem. Then you found out it was quite a difficult problem and continues to be a research question.
That's right.
You presented these ideas to a research group in Prague, and they gave you space. They gave you an opportunity to kind of co-create with them. You were able to advance that work. And you also got an opportunity to work with this mentor that you're currently working with. And that got into Berkeley and even as a high school student, right?
That's right.
So you come from then a science family, though. That's what it sounds like.
I wouldn't say that. My parents are not scientists. My one of them works in management, the other in HR. My grandma did have some connection to science. So my grandma had that connection. So there was a bit of it, but not a lot. I think the first time that I told my parents that I wanted to pursue a PhD at some point after my undergrad, there was a bit of friction, even though they were very supportive in anything I do, and there was a bit of friction there. So I wouldn't say it's a scientific family.
It's interesting. I was talking to a person, and I noticed that you get like Forbes 30 under 30 lists, et cetera. Europe. How does that happen? Do they approach you and say, we think your work is really interesting, and you're now being selected to Forbes 30 under 30?
I think you're muted, Stephen, but yeah, no, it's that experience was really interesting. I'm not sure how it works for most folks who are based in Central Europe that can like go to a photo shoot and go to like an event or an in-person meeting. But for me, they reached out and asked for an interview in person, even though I'm based out of Stanford. And I said, I'm happy to hop on a Zoom call and do the interview, but I can't just travel to Prague. And they're like, no, you really want to come to Central Europe, like for this meeting and this interview. And so I did. And that's where they told me. But there was no sort of, no prior communication or survey or anything. And they just told me in person.
I see. So you appeared on their radar screen, and then they reach out and say, hey, we want you to be, we're going to do an interview, but it's an interview to be selected as a Forbes 30 under 30 list in Central Europe. You also received the Innovator of the Year award in the Czech area, and the Czech AI Personality Award. So how did that happen?
Again, both of these were well, actually, so the AI Personality of the Year for Czech, that happened in a very similar fashion. Someone just reached out and said that I won the award, and it's funny, one of the elements of the award, except for the actual event and some press, was a ride in a Cybertruck, but I was not that interested. And I also was not in Europe, so I gave that to my younger brother Toby, so he had a good time. But so that was again very similar. Just someone reached out with the award for young scientists in the Czech Republic by the Department of Education and Science. There I actually had to submit a proposal, or like submit my work. So there was a process behind that award. There were, I believe, 2 rounds where the first round was submitting an abstract and then some demonstration, and then the second one was actually presenting the research in front of a committee. So they had a bunch of folks from the Academy of Sciences and some external experts from industry, and that was the committee for that award.
And then you got this Moonshot award. So how did you get that?
Yeah, Moonshot started, I believe, 2 years ago as this venture to connect young change makers from different parts of the world, and they had different categories. One was about innovation, but there were also just idea categories and sustainability and other areas. They're very aligned with the SDGs. They're connected to the UN and also to the Aspen Institute, and that was just phenomenal. There was also a bit of a journey leading up to that award, and they have a system for submitting your ideas or your projects in your ventures. So I had to fill that out. It was funny. I actually did that during that first summer in Berkeley. So I was in Berkeley sitting in the Free Speech Cafe, and I was filling out my Moonshot application. And so once you fill that out, there are again some interviews, some presentations, and at the end, if you're selected, there's this amazing week in New York where there's like a formal kind of award ceremony, but also a lot of meetings, a lot of super cool activities, a lot of experts, a lot of mentors come in from all over, and it's just phenomenal. So that's Moonshot.
Then you're a 2-time Apple WWDC scholar. How does that happen?
Apple has this conference dubbed up, or WWDC, for developers every year. And they have a program for students, high school through, I think, PhD, to submit their apps or their ideas. And so I did this as an elementary school student, actually. So I applied the first time in 8th grade with an app that got rejected, but then again in the 9th grade, and that got accepted. And so I was 14, I got accepted to this Apple scholarship for their conference. And the idea is they fly you out to San Jose for their conference. It's a week-long thing. But I was 14 out of Eastern Europe, and my parents somehow allowed me to travel solo, across the Atlantic, and the continent, to San Jose, and so that happened, and that was one of the pivotal moments for me, where I saw the culture of the Bay Area, and just how I connected with folks here and with my peers as well. And yeah, that was amazing. And you also get to see the headquarters, the loop, or the spaceship. Yeah, it's just phenomenal. You get to hang out with Tim Cook. Yeah, that was a good time. And so I did that twice. But the second one was during COVID, or like the first year of COVID. So that was remotely, unfortunately.
Well, what's that like, Tim Cook?
Oh, it's great. It was really surprising to me just how thoughtful, and also actually on the same page he was with all our projects, because he has so much going on, and yet he took the time to read about our projects, and to have, he had questions and ideas and some feedback. And even though it was very brief, of course, he's a busy man. It was great. It was really meaningful. So I was really impressed.
Well, you got your research published in Science and the Proceedings of the National Academy of Science. How does that happen?
Right. So the Science was a feature about our research, but the PNAS, those were published articles by us. Yeah, we were working on deepfake detection with Professor Farid, and this was really inspired by the deepfake that got released of President Zelensky of Ukraine at the start of the war in Ukraine. And we saw just how impactful that can be, because this deepfake got on the national TV network for a couple of hours. And this deepfake was telling in President Zelensky's likeness and in his voice to lay down arms and stop fighting. And it took President Zelensky himself to go out and debunk this deepfake. So we saw that, and we thought, okay, we need to do something about this. And so we built a system that combines facial, gestural, and vocal mannerisms of a particular identity. So in this case, President Zelensky. And it builds a system that learns these mannerisms and is able to utilize some gaps or some things that the deepfake engines of today still don't quite get or cannot really alter, and is able to detect those deepfakes. And so we built that system, and we published that in PNAS. So that was my my first like big journal article. That was I think junior year of high school. And yeah, it's really tricky to publish things about deepfake detection, because on the one hand, you want to inform folks about this method and make sure that people, in the right places can use that technology for good. At the same time, you want to prevent the bad guys from using your deepfake detection to improve their engines to be able to circumvent that detection. So there's always like this fine line to walk. So some details are not shared. We don't open source our code also, but yeah. So that was the PNAS paper.
I mean, you've done a number of speaking engagements, like the United Nations conference, Stanford Online Trust and Safety Conference. You've done the EU Disinformation Conference. I met you at Futureport Youth Conference in Prague last year. How do these invites happen? They just hear about your work and you get somebody saying, hey, would you mind speaking? How does that work?
Pretty much. I go to scientific conferences, and for those conferences, I actually apply. I submit papers or talks or proposals, but then I talk to people, and I really, what I enjoy about computer science is that we're at a time when computer science really touches almost all other domains of work and research and just public life. And I really embrace that. Like I want to make sure that I learn from folks from different industries and different spaces or different contexts, and also inform their work. And so just by talking to people, those invites just happen. I don't ask to go there. It's just always kind of happens.
And then you co-founded and exited Verify or Verify, I guess, and it's an AI-based app for disinformation analysis by Google. What does that mean? You co-founded and exited, and you were able to sell it or it got acquired? What happened there?
Right. So Verify was a startup back in Europe, and the idea was to analyze disinformation or analyze news, but not in the usual way of saying like, oh, this is fake or this is real. I think that's problematic on many levels. The idea was to instead inform readers about different attributes or different features and mechanisms that the article is using in terms of its narrative and in terms of the framing and the resources and information it pulls in. And so at the end, what you get as a user of the system is this report with potentially misleading parts of the article or things to look into, and it's just like a report. It's like this like quick kind of indicator of how transparent and biased the article is. So I moved to Stanford to pursue my undergrad. And around that time, Google got interested in actually kind of getting more involved and working with Verify and kind of spearheading that in Central and Eastern Europe. It didn't get acquired because it was a nonprofit to begin with. But I kind of left it there with my co-founders to then like work with Google and advance it further. But yeah, so there is money in Google provided like a lot of money, but then I chose to just leave it there because it's a nonprofit, and I thought it was serving a better service there with the company.
Well, you talked about when you were in high school, you developed this sort of a sign language system, right? And you've been improving on it. And so what's happened to that work and how has it progressed and where is it used now? And can you bring us up to where it is today and where you think it's going to go in the future?
Yeah, right, for sure. So the sign language work, what was happening or I was working on it for multiple years and really advancing it. I published a state-of-the-art a paper at WACV in 2022 that was the state-of-the-art on sign language recognition. And that was actually open source, unlike the deepfake detection work that I do. That was fully open source, so people could use the models, the code, train it on their own languages, their own data, and integrate it in apps or services. And since then, we had a bunch of improvements upon that work. But over time, as I got more engaged with the deaf and hard of hearing community, I realized that as a hearing person and as a non-member of that community, I had some ideas or some maybe preconceptions that might not have been accurate about how this technology should be used and implemented. And so I made it my goal to put all this work that I had done into a usable format for deaf and hard of hearing folks from that community to actually put into work. So the app is being used at a bunch of universities in the US. For example, at Tulane to teach sign language. It's used in courses. People from, for example, Brazil are apparently using it in some governmental organizations. So different places are using it as like an open source tool for their needs. But it became clear to me that I shouldn't be the one who actually goes and like puts it into like an app or something. That should be someone from the community. And so I wanted to make sure that I'm being both helpful and also respectful of those considerations.
So can you talk about more about your work on deepfakes? I mean, you did something with Anderson Cooper, you were on CNN, you looked at Sora, Runway, VO, benchmark, data sets, detection, AI systems degrade, et cetera, et cetera. Can you get the data about that work?
Oh, for sure. Yeah. So there's a couple of things happening there. The Anderson Cooper project you mentioned was a lot of fun. So this was our joint effort to inform folks about the dangers of deepfakes and just how easy it is to create one. So in the summer of 2022, we from scratch on like a consumer laptop that I use for classes and for school, we decided to build a deepfake engine for Anderson with just open source stuff, only open source data, nothing proprietary, nothing provided by CNN, just whatever we can find on the internet. And we built this deepfake pipeline, myself and my advisor, Hani Farid, and it was good enough to air on CNN in primetime and to open their show. And it was really funny actually because by the end of this I want to say 3 or 4 week long project, we were kind of sharing the work in progress deepfake or video with the team. And at one point, our contact decided to actually show it in one of their meetings, with the producers and managers of the show, and they showed it in front of everyone, and most folks didn't know it was a deepfake, and a lot of them actually didn't notice, they didn't register, and so this contact came back to us with all these reactions from folks, and it was really quite funny and interesting. So at that point, we knew that it was ready for the air, because if it could fool people who work with Anderson, that was a good signal. And yeah, so in the show, this deepfake Anderson we built opens and kind of establishes that it's really easy to make these deepfakes. A high schooler can do it with a basic laptop, and then the show for an hour explores different risks of AI, but also different positive use cases of AI. So it's I think a very balanced view on AI, on like what can be done and what can be like what positive impacts it can have, but also what are the dangers and risks we have to look out for. And we also appeared on that show and discussed some of those things. So that was the kind of like the public kind of messaging or making sure that the public knows about this threat, part of the work. And then, as we already talked about, there's a lot of work on detection that we work on. We've been working on that for multiple years. And we also are trying to equip the community here, the scientific and research community, with resources to do this kind of work. So last year, we open sourced DeepSpeak, not DeepSeek, DeepSpeak. So we were kind of ahead of the game on that name. And this DeepSpeak is a data set of state-of-the-art deepfake engines. It has a bunch of different engines, different tools, different identities, and we built this data set of realistic deepfakes and really where the field is at. And people can use this to build detectors, to analyze their readiness for deepfake threats in companies, different kinds of use cases, but it's out there. We're going to release version 2 very soon for this year, and we're planning to update that every year as new engines and new technology gets developed. So that's one thing we do for the community, kind of on the inside. And then we're also trying to be ahead, right? Because like the deepfakes of the present are mostly changing what a person says in a video, but there's this whole new emerging scene of text to video generation where it's kind of similar to DALL-E or Stable Diffusion, where it's not just changing what someone says in a video, but it's really going from text to video. It's like free form video generation. And there could be a lot of damage with that, a lot of very cool stuff, but also a lot of damage. And so we want to make sure that we can detect that. So that's one of the things that I worked on at Google this past summer. So we had a project on that, and we're still continuing to enhance those technologies further as well.
So when you're working at Google, are you working with Eve Anderson, who heads up accessibility, or Jeff D? Do you have any contact with the chief scientist there, or no? Or...
So as student researchers, we do have like some events with like Jeff Dean, but we didn't work directly with him. I guess we were like under him as student researchers, but it was mostly just like this kind of leadership contact with like some like high level vision, and then we worked with our direct managers and mentors and the respective teams for the topic that we were working on.
And you're working on AI model poisoning and collapse. Can you talk about that?
Yeah, so 2 years ago, we discovered that there's this really crazy phenomenon or behavior of AI models, specifically generative models, where when they see their own generations as training data at input, they actually can collapse in some circumstances. And it's this really kind of interesting phenomenon where as we're using large language models, these text-to-image generators, we're also sharing them online. We're kind of polluting the online space that is then used to scrape new data sets. So there's like this loop happening where we build these models, we generate stuff, text, video, images, and then the companies again come to the internet and kind of scrape it back. And so this AI data is getting used to retrain the models. And we found that for text-to-image generators, as little as 3% of AI images in a training set can poison the models. And what this poisoning means is that the model produces corrupted or kind of incoherent images that are kind of trippy or kind of strange. And the models can be fixed, they can be healed, but it takes time and it's hard to do that. So we did this work, we described exactly under what circumstances it happens, and we use this as an argument to further support watermarking and tagging of AI content, because it's not just in the interest of consumers to know when an image or text is AI, perhaps online. It's also in the interest of the companies, because if they want to retrain on the internet, they better need to know what is AI and what is not AI to be able to train models that are not corrupted or not poisoned.
And so why do you think that's happening?
It's a great question. We don't exactly know. And it comes back to this idea that these models are really mostly just black boxes. Like we can describe in math and in precise formulation, like how these models are trained and how they converge, but we don't really know fundamentally why they work. We do have a couple of theories. We do know that when the models are presented with this content that they themselves generated, they tend to create these very dense representations on the inside, because on the inside, these models operate with vectors, with embeddings, right? And it's like this high dimensional space in which the models represent ideas, concepts, and through which they can generate images and text, any modality. But what happens when this AI data is used to retrain this model in this space is that these representations became very dense, and so perhaps that is somehow corrupting the way that the model synthesizes new content. But we don't exactly know. There are a bunch of hypotheses. Different folks have confirmed this phenomenon later. They have reproduced this for both images and text models. But no one really exactly knows why this is happening.
So I'm going to ask you a series of questions, Dan. Have you looked at the sparse autoencoder like Gemascope? And, there's a thing called neuropedia, so you can sort of see what's happening. And other research groups saying, hey, there seems to be some kind of organization that's happening in these models. Can you speak about that?
Yeah.
Questions. So.
Yeah, for sure. Sparse autoencoders are a really great way of making sense of concepts or ideas in our kind of human way of thinking that the models are representing without imposing our own biases or without imposing our structures because they might be different from that of the model. And for example, with image generation, the sparse autoencoders enable us to distinguish different features. Like, for example, whether something is to the left or to the right, or it can be even more fine-grained, like different features like eyes or noses or like the different parts of faces, for example, and they can then be used to make sense of how the model is representing different concepts, and also how the model is leveraging its training data. We can use this to analyze whether the model is actually learning what it's supposed to be learning. So it's I would describe it as like a way for us to, in a data-driven way, represent and organize these concepts for different models, different modalities. It really emerged out of this field of explainable AI. And at first, in my understanding, it was first used for large language models, where it saw a lot of success, and now it's being used for images as well.
How about this research that they could see these these models self-organizing into sort of specialty areas? What do you make of that?
Yeah, I'm not I've not read up on the latest works in that, but I think it's really interesting that these models are creating these centers. It's still I think this whole research question I think is in its infancy, in the sense that there's so much we don't know. And so I think it's very exciting because we do see these initial signs of some sort of organization, some sort of clustering that in a very loose sense is mimicking this sort of specialization in our brains. We know that there are centers for different capabilities, different tasks, and we do see something along those lines in some models. And so I think that's very exciting. I also think that we should be careful when we talk about these models, because and I probably do it myself quite often. We tend to use human verbs, human adjectives on these models, and I'd be careful there because that comes with a sort of baggage of different considerations to be made about these models. But yeah, I think it's super exciting. I think there's so much left to do, and I think that in both computer vision and NLP, all those subfields of AI, there's a lot of work happening on the generation, but over time, and there's a lot of hype. Right now I'm at a conference here in Arizona, and every other paper is about generation synthesis. Super cool, great stuff. But I think that over time, and I would hope to see this, we'll be more thoughtful, or we'll be spending more of our energy as a field on these questions, like making sense of these models and understanding them, because I think that once we understand these concepts, we can then build better models and more safer models as well. So yeah, I think it's super cool.
Have you looked at Kahn networks? These Kolmogorov-Arnold network models at all?
I haven't worked with them, so I'd be hesitant to make any strong inferences.
How about Google Titans? Have you looked at that work at all? Or
I don't think so.
Okay, so I'm going to give you a series of topic areas to see if you've investigated them. So Kahn would be one, Google Titans. Second, Transformer Squared, a little bit of controversy, right? Where they have to really pull back some of their claims. That's kind of my feel for it. Maybe I got it wrong, but have you looked at their Transformer Squared mythical stuff at all? Or?
is that the kind of work with like agents for discovery and for building new kind of emergent, maybe not?
Yeah, really, it's kind of like a hierarchical way of doing things, so we get more efficiencies and things like that. How about the Figure AI company came out with their VLA helix model for generalizing on the robots and the embedding. I thought that was really interesting. Again, these could be topic areas you haven't looked at because it's just breaking. So I don't know if you looked at their VLA helix model.
So I do know about them. And I think this idea of embodied intelligence is really interesting because right now, when we think about, or when most people outside of the field think about I think most people think about language models because that's the most I think exposed part of the field and also the most effective at delivering like consumer grade applications and it's super cool. But this idea that these models are mimicking human intelligence, I think is complicated because these models to achieve this level of like human level or in some tasks human level performance in language, they need to see billions of lines of text. They need to see so many documents. Basically, the entire human knowledge as stored digitally in text, they need to see it to be able to reach this performance, right? But then if you think about babies or humans, a baby doesn't need to read the entire library to get their basic intelligence. For them, it's a bit of crawling, a bit of noises, a bit of exposure to the environment, to the world, and then maybe a couple books, at elementary school, and they can reach a similar sort of performance at some point. And so I think that as we combine this amazing potential of language models with the knowledge of vision models, and also with embodied agents because they can interact with the world and learn from experience, I think that's when we can actually start thinking about or like talking about more general intelligence. So I think their work, even though it's now focused on like specific applications or specific industries, I think it's really this much broader idea of embodied intelligence, also combining these modalities that I think is really interesting and really promising. So I really love to see this.
Yeah, I mean I just recently had a conversation with Jan LeCun, right, chief scientist at Meta, but he also just won the Queen Elizabeth Prize for his work in AI with Jeff Hinton and Yoshua Bengio, and of course he won the HCM Turing Award. But he has this JEPA model. Have you looked at his ideas? Because he doesn't think that LLMs are going to achieve some of the things that maybe Jeff Hinton feels that they may achieve or others. What are your feelings about his hybrid kind of thinking? And well, you need more. Which school are you in? Kind of the Ilya Sutskever and OpenAI, that we're going to have super intelligence with these continual reasoning LLM kind of models, or you say, no, we're going to have some kind of symbolic, neurosymbolic, hybrid, whatever, that's joint embedding, predictive architecture or something like that to JEPA. Do you think it's more in that direction? I mean, what you're thinking in this area? And Google Titans is kind of adding human-like memory capability and so could do more. So that's probably more on the lines of LLMs and just increasing its capability. Which school do you sit in? Do you think that you see the ARC-1 test in December last year, and the O3 model of OpenAI exceeded the ARC-1 test. Now they got an ARC-2, and that was supposed to be a benchmark for some elements of AGI. And then some people are now thinking that we are seeing glimmers of AGI, and it's really a matter of days and years to get AGI, and then that's going to be the path to super AI super intelligence. Where do you sit in this?
A lot of big questions there. I'll preface this by saying that I mean these are great questions, and I'm really interested in this. But I need to preface this by saying that I think anyone as like even like super experienced researchers often make mistakes in these predictions. And so someone as junior as myself like my predictions should be taken with a grain of salt. And these are inferences that are really hard to make because it's really hard to predict how fast a technology can progress here. If you think back to any predictions as to like when we would, achieve AGI or just like AI, I think it would be very hard to think about the linearity of that because one invention, like one, advancement as self-attention and transformers can really like move the field, like timelines. But I think with these two schools of thoughts or schools of thought you described, I think I'm like somewhere multimodal side of things. I think that LLMs, as I said, are super interesting, super capable. But to me, it seems like there are some things that just can't be represented with language. And maybe this is like a egocentric kind of inference based on my human, and also from just like being and experiencing with the universe, with other agents, with other entities, that is essential to some aspects of intelligence. And so maybe you can achieve super impressive benchmark performance, and maybe reasoning will take us a long way. But I think that at some point you need to bring in these other modalities, at least in some capacity. And I think really at the intersection of those, with maybe some neurosymbolic framing that could be improved to where we're at now, you can really achieve greatness. So I would lean in that direction. In terms of timelines, every time there's a new benchmark, people say, oh, this is the last test that the humanity has for these models. And then, come Thursday, it's beaten by like a bunch of models. So I'm not sure. I would say, I think beyond that, it's really hard to predict anything. It's hard to predict what's going to happen within computer vision in the next 2 months. So, I think that's my thinking. I would say that I feel like it's coming, but I'm not sure as to exactly when. And I definitely sit in like that position, kind of leaning towards the more neurosymbolic, multimodal side of things. But again, I might be proven by Thursday.
Yeah, I mean, if you look at Kurzweil, I mean, a lot of the things that he said over the last decades are coming true, right? So
yeah,
and in his timelines, not in the timelines, and so it's an interesting time. You also took on a project with Nonflict. Can you describe that project? And Stephen Hecht and a nonprofit called Million Peacemakers.
That's right. Yeah, I'm working with them on so Nonflict and Million Peacemakers have this amazing framework for dealing with conflict and conflict resolution, really. And they're focusing now on youth and how to make this technology and to different youth organizations and youth worldwide, and also go beyond that. And I've been working with them on an AI chatbot, on an AI system to make this framework. And it's been a great time because I get to use the research experience and also the research outcomes that we get out of the lab in a direct applied way. Beyond just this AI chatbot, we also have translations. So AI-powered translations. This is one of the few like good use cases of deepfakes. I think is translating content to any number of languages. Is the lip movement really makes it feel like it's being spoken in that language. So we now have the content, the video content that Nonflict has available in many more languages, and there are more features that will come out soon as well. So that's been just a great collaboration and work with Nonflict.
Yeah, we're for some reason you're freezing sometimes, so hopefully the audience has got enough between when you're frozen and in your explanations and things like that. We'll go to the sort of last series of questions because we only have a few minutes left. Is there any area that you want to address that we haven't talked about?
Yeah, I don't think so. I don't think so.
And then the final question is, do you have any recommendations and or questions you want to leave the audience?
I think if there's anyone who's just starting with AI or computer science, and I was in those shoes, which opportunity now with AI and with CS at large, that is still unexplored. I think the notion or the narrative now is that AIs will replace engineers and different roles within computer science, and that is true. That is happening in some extent, and so that might be discouraging from like entering this space, this field. I would actually encourage folks to go at the margins, but also like at the intersection of computer science with other fields, with other problems, with other contexts. And I think we're just getting started. So this narrative that there's going to be in the market, I think that will happen for sure with software engineering, but I think there's much more that we don't yet know about it and how it will be structured. So I would just encourage folks who are like starting out, maybe high school or college, and are thinking about computer science, like I say go for it, because there's much more in store.
Yeah. Unfortunately, you're freezing here and there, and hopefully the audience is getting enough of your content. But what I'm hearing is you're saying there's a future in computing science, there's a future in having that kind of science background. There's definitely a future in AI and machine learning and sort of near adjacent areas and things like that. So go for it.
That's right. I apologize for.
When do you graduate with your undergrad? You're still in your undergrad years, right?
Yeah. That's right. I'm sophomore in college, Stanford.
Yeah, freshman, sophomore, junior, senior. So you're just in your second year yet.
Yeah, that's right.
But you've been given quite a bit of freedom, right? I mean, I see you keynoting around the world, things like that, and yet you're a full-time student. So how does that work?
After this meeting, I'll hop on Zoom to. So it's a lot of flexibility from my professors who are amazing, and also having amazing friends who support me and share, maybe if I have to skip lecture, but then I have to make up for it. So on for example, for Futureport in Prague, where we met last year, as I was flying from San Francisco to Prague, this like long flight, I spent most of it just like working on homework or working on lecture notes, just reviewing and making up for stuff that I missed at Stanford. So it's just like a lot of makeup work, but also a lot of flexibility and good friends.
So what are your career plans? That is, you want to get your master's, then your PhD, or maybe go directly to a PhD. I mean, what are your plans?
I would go straight into a PhD after undergrad, and I know that I want to do research and science. I think I want to, but it's still a long time from now, so things might change. I think I really enjoy the position of being in academia and then government and making it applied, but really doing like fundamental science and discovery and research. But we'll see where that takes me. I know that I definitely want to do a PhD, and then we'll see where the market is, and also what kinds of opportunities there are in AI and how AI work and research will be done at that point. But yeah, I want to go into a PhD after undergrad.
Yeah, and then I guess part of that journey is you've got to have a supervisor for your PhD. So have you been engaging in any of those early discussions about somebody who would act as your supervisor or not, or is it too early?
I think programs. So there are some ideas I think floating around, but I'll be working on that over the next year and a half for sure.
So Maty, thank you for coming in. You gave us a great picture of your journey from when you were 6 years old and your grandparents sort of computer that wasn't doing anything, and just sort of self-teaching yourself from websites to coding to start creating this sign language app, and then getting mentored by a research group, and that accelerated your work. And then, getting more sophisticated in your application developments that you were doing, getting this opportunity to be mentored by professors, and having this sort of pathway, and of course, publishing research and developing novel science. It's been an incredible journey. So thank you for coming in and sharing your insights with our audience.
Thank you so much, Stephen. I really appreciate it. Thanks.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.